DSL-Lab is a modular ecosystem for online user studies of end-user programming languages for robot automation. The starting point for creating DSL-Lab was the question, how can we simplify programming of robot automation for end users? And more specifically, we were looking into how can behavior-driven development be used as a domain-specific language for robot automation. Behavior-driven development is a way of testing software systems based on scenarios, similar to the way of using unit testing. And the question was, could this way of creating scenarios be used for programming robot automation, and would the more natural language compared to traditional programming help the end user program them easier? So for testing this, we created an A and B setup. For the A setup, we used JavaScript as a control for ordinary general purpose programming language. And for the B setup, we used behavior-driven development as an intervention to test the potential. As a metaphor for robot automation, we created a task consisting of two subtasks. The first task was to sort the pieces into their respective colored positions. And secondly, it was to move the pieces from the colored position to the end position in a specific order. In this case, it was red, green, and blue. So the different users had to write the code to program a robot to do that, either in JavaScript or behavior-driven development. And in our initial setup, we used an actual physical robot with physical pieces for them to test their code. But it quickly became clear there were some limitations with this setup. We were using different editors. We were bound by the physical setup. We did not have automatic logging or automatic task verification. And it was in general hard to scale and have consistent tests between the A and B setup. Furthermore, comparing different programming languages is also about the frameworks they're embedded in. Through our initial testing, it became clear that a lot of factors in the framework around this actual code was just as central. For example, how much time did they use to press run for the first time can be an indicator of how they familiarize themselves with the system and how they get to know what different pieces of the code does in relation to controlling the robot. So it became clear that we needed an ecosystem with consistent and interchangeable components where we can do automated testing, have automatic metrics, use different domain-specific languages, have a simulated environment, and be able to scale it for multiple user testing. And this is where DSL-Lab comes in as an ecosystem with consistency and interchangeable components. Compared to our original setup where we had different frameworks from the A and B setup, we now have a consistent system for this where the editor, console, and simulation are integrated into the same ecosystem. This means that the only differences in the test setup is the syntax of the code and the color coding, but the rest is kept consistent. Similarly, the way this is unified also allows us to create interchangeable components. So right now we are using the robot arm as a metaphor, but we could just as well use a robot platform as seen in warehouses to move packages around. Because the system is integrated and we have full control of everything, we can also start to do new things, like we can give feedback to the user of when they have actually solved the tasks, and we can also log how long time it takes for them to solve each of the tasks. We can also give visual clues as feedback for progression. So here's an example of indicating that it is correct to put the red piece on the red position with a little white line around it. And most essentially, behind the scenes, we can track whatever the user does. So this tracks when the user opens the help panel, when they copy paste, when they run, and when what errors they get from their code, and so forth. All of these elements are collected in a report that can be shown as a timeline. In this timeline, you can see a snapshot every 5 seconds of how the code progresses. You can see all the interactions of copy-paste, console errors, console outputs, when they open and close the Helm panel, and so forth. So you have a highly detailed overview of all the interactions during the test and how they solved the task and how they progressed in it. This gives a good baseline for creating a quantitative analysis where you can count the amount of times each test was run, how many errors they got, when they started the first run, and so forth and so forth. This report and timeline is only accessible by the admin. Finally, the system is written in JavaScript and HTML and is therefore purely web-based. This means that there's no physical robot it's tied to, no operation system level binary libraries that needs to be installed on the computers, and that allows us to scale it significantly because it only requires a browser to run. This was the DSL-Lab, a modular ecosystem for online user studies of end-user programming languages for robot automation.